current, density, conductivity and resistivity of a semiconductor. Suppose this is a semiconductor. This semiconductor contains holes as well as electrons. So suppose the N is equals to electron concentration per meter cube, and suppose P is equals to hole concentration, number of hole per meter cube, and the charge will pass through this cross sectional area. Suppose this cross section area is A, so A is equals to cross sectional area of the semiconductor. Since this is a semiconductor, that's why there are two types of charge carrier. One is electron and one is hole, and this semiconductor is kept under some voltage, suppose V. So that's why the carrier will attain a fixed velocity. This velocity is called drift velocity. So that's why we take Vn is equals to the drift velocity of electrons in meter per second. As well, the drift velocity of hole is given by Vp is also in meter per second. Now we have to calculate the current through this semiconductor. Suppose current I can be calculated as total Q divided by time. So current through this semiconductor can be calculated as total charge leaves this cross sectional area per unit time. So we have taken that Vn, the drift velocity of electron in meter per second. That means the electron will move Vn distance in 1 second. That means the charge inside this PQ region will pass this cross sectional area in 1 second. So we have to calculate the total charge inside this PQ region. Now the volume of the PQ region is given by the length, this is length into cross sectional area. So length of this conductor is Vn. This length is traversed by these free electrons in 1 second. So the charge, number of electrons in PQ region is given by, this is volume multiplied by the electron concentration. So this will give the number of electrons in this PQ region. Now the charge, the total charge in PQ region for electrons is given by Vn into A into N. This is the number of electrons. If I multiply with the charge. Suppose this is E is equals to charge of electrons, then it will be the total charge for the electron. So you take it total charge for electron QE. So the current for electrons can be calculated as total charge due to electron divided by time. So total charge is given by Vn A N E divided by, this is 1, T is equals to 1, because this distance Vn is traversed by this electron in 1 second. That's why we can take T is equals to 1. So it can be written as Vn A N E. This is the current for electrons. So the current density for electrons Je can be written as IE divided by A. So for this case it will be Vn N into E. This is the current density for electrons. Now this is a drift velocity. So for drift velocity you can write that this is the, suppose this is V. Okay, for this V, this is V is volt. So for this V there is a electric field. So for this electric field you can write that this Vn is proportional to E. So Vn is equals to mu n into E. This mu n is called mobility. So we can write that this equation is as mu n into E into n into E. This is the current density for electrons. Similarly, you can write, you can calculate the current density for holes, can be written as Jp is equals to, this will be mu p into E into P into E. This will be the current density for holes. So I have calculated the current density for electrons and current density for holes. So these two charge carrier contribute the current through this semiconductor. That's why we can say that total current density in semiconductor can be written as Je plus Jp is given by, this is E is common. So you can write that mu p into mu n into n plus mu p into p is into E into small e. Okay, so this is the total current density for semiconductor. Okay, this is the equation number 1. This equation number is very important for our next calculation. Okay, so this is the total current density for semiconductor. Now if I apply the Ohm's law through this semiconductor materials, so according to Ohm's law we can write Ohm's law in vector forms. If I want to express the Ohm's law in vector forms, then it will be J, current density is equals to sigma into E. This is the mathematical expression for Ohm's law in vector form. This is vector, this is also vector. This is conductivity. So if I compare this equation 1 and 2, we can easily calculate that this term sigma comparing 1 and 2. We can write that this sigma is given by, this is n into mu n plus p into mu p into E. This is the sigma. This sigma is called the conductivity of this semiconductor. So this sigma is called conductivity of the semiconductor. This equation is sigma. Now this sigma, this is a pure semiconductor, extrinsic semiconductor. So sigma can be written as n mu n plus p mu p into E for extrinsic semiconductor. In extrinsic semiconductor. If this semiconductor is intrinsic, pure semiconductor, then what will be the equation of conductivity? For intrinsic semiconductor, Ni equals to N equals to P. So that's why intrinsic semiconductor conductivity for intrinsic semiconductor can be written as Ni into mu n plus mu p into E. This is the conductivity for intrinsic semiconductor. For intrinsic semiconductor. Now, if I want to calculate the conductivity of a conductor, so what will be the expression? So conductivity for conductor can be written as, so conductivity for conductor. Conductor contains only free electrons. That's why the conductivity is given by N mu into E. This is the conductivity for conductor, N mu E. This is the conductivity of several conditions for semiconductor. Now, if I want to define resistivity, so resistivity rho is defined as the inverse of conductivity. So resistivity for conductor, it can be written as 1 by N mu E. This is for conductor. Now resistivity for extrinsic semiconductor. Extrinsic semiconductor can be written as 1 by, this is N, so N mu N plus P mu P into E. This is for extrinsic semiconductor. For intrinsic, resistivity is given by 1 by Ni into mu N plus mu P into E. This is for intrinsic semiconductor. Okay. This is the several number equation related current density, conductivity and resistivity. This formula can be used to solve this type of problem. There are two problems related to this current density, conductivity and resistivity. Now I will solve these two problems. Problem number 1. Free electron density in a conductor is given by this. So conductivity of a conductor is given by 1 by 1.6 into 10 to the power 22 per minus semi to the power minus 3. Electron mobility is this. So mu is given by 10 semi square per volt second. What is the resistivity? You have to calculate rho for this equation and this problem. So we have taken that, we have already proved that resistivity of a conductor is given by 1 by n e and mu. This is the conductivity of conductor. Resistivity of a conductor is given by 1 by n e and mu. Okay, so we have to only put this value. N is given by resistivity, conductivity, free electron density, not a, this is n, this is n. Free electron density is given by n is this. So this is n. So 1 by 1.6 into 10 to the power 22 multiplied by, this is mu is 10, this is semi to the power minus 3, this semi square, this is volt second. So value of E is given by 1.6 into 10 to the power minus 19 coulomb. So this is cancel out. So it will be 1 by 10 to the power 23. This is 10 into 10 to the power minus 19. So it will be plus, this is minus, so it will be 10 to the power this is 10 to the power 4. This will be minus 4. Okay, this will be minus 4. So resistivity can be written as ohm semi. Okay, ohm semi. So this is the solve of this problem 1. Now I will solve the problem number 2. Now this is a problem number 2. Problem number 2 is given as pure silicon has an electric resistivity. So electric resistivity for electric silicon resistivity rho is given by 3000 ohm meter. If the free carrier density in it is 1.1 into 10 to the power 6 per meter cube. So free carrier density, so it is n. N is given by, this is Ni suppose. So 1.1 into 10 to the power 6 meter to the power minus 3. And the electron mobility is 3 times that of hole mobility. So mu n is given by 3 of mu p. This is the electron mobility is 3 times that of the hole mobility. calculate the mobility of holes and electrons. So you have to calculate mu n and mu p. So how to solve this problem? So sigma is given by for intrinsic semiconductor, it is given by Ni mu n plus mu p into E. This is the conductivity for intrinsic semiconductor. Now resistivity is rho I equals to 1 by sigma I. Okay, so this can be written as Ni into, if I replace mu n by 3 mu p, it can be written as 3 mu p plus mu p into E. So it will be Ni into 4 mu p into E. So it can be written as 1 by Ni 4 mu p into E is given by this 3000 ohm meter. So from this equation we can write that mu p is given by Ni given by 1 divided by 3000 into Ni into 4 into E. This is the equation for mu p. So if you put this value Ni and E, okay, so this is 1, this is 3000 into Ni is given by 1.1 into 10 to the power 6 into 4 into the charge of electron is 1.6 into 10 to the power minus 19. So if you calculate this value, it will be 4.738 into 10 to the power 8. This is mu p, so it will be meter square per volt second. So this is the mobility for holes. Now if you want to calculate the mobility for a electron, so it will be mu n equals to 3 mu p. You have to only multiply this value 4.738 into 10 to the power 8 meter square into volt second. So in this way you can solve this problem.